Hey guys, Christian here again. We've got another logarithmic equation today. So we're going to use the same method that we use typically for these types of problems. When you've got a series of logarithms that form an equation and they all have the same base, you can typically combine them using the log laws to create much simpler expressions that we can then solve. So because we've got 2 logs on the left-hand side, 2 logs on the right-hand side, no external terms, we're able to simply combine the left-hand side and combine the right-hand side, and then hopefully we should be able to cancel out these logs. So using the first logarithm law, on the left-hand side, when we've got 2 logs that are added together, we can combine them by multiplying the arguments together. And we're going to use the exact same rule to combine the right-hand side. Once we get to this point, we've got a single logarithm on the left, single logarithm on the right, no external factors. We can apply a base, basically, which will cancel out. So technically what we do here, in really simple terms, we're going to cancel out the log 3 on both sides. But in order to be specific, what we technically do is we apply a base 3 to each side. And we do that because the logs are base 3. And the base 3 with the log 3 actually cancel each other out. And we're only left with the bits that are inside the brackets. While we're at it, I'm going to simplify those. So the left-hand side would now be x squared minus x, just expanding those brackets out. Right-hand side, same sort of thing, 2x plus 18. Now we've got a quadratic problem, and a quadratic problem is something we can actually deal with. So whenever we've got a quadratic problem, the solution is to move everything over to the one side of the equation, let it equal 0, and then either factorize or use the quadratic formula to try and finish it off. So I'm going to move everything over to the left-hand side now. So I'll keep the x squared as it was. We've already got a minus x, and then we're going to minus 2x from the right-hand side, so that'll become minus 3x, and I'll minus the 18 as well. And that can equal 0. Now, whichever you're more comfortable with out of factorizing or the quadratic formula is the way to go here. Now, I'm quite happy just to factorize a problem like this. So we can have x minus 6 and x plus 3, and that'll give us the factors we need, and then we can use the null factor law to finish that off. Now, if you want to use the quadratic formula, you technically can. There's nothing wrong with it. It's probably a little lengthy for something that's so simple to factorize, but it's entirely up to you. Once you've got these two solutions, there is one last thing you actually need to look at. And you've got to look at, do these solutions fit into the domain of the logarithms? Because logs have an added twist. While both of these solutions are answers to this quadratic, they might not be answers to the original problem, because you can only take the log of positive numbers, which means that in this question, we've actually got a restricted domain. Now, this particular log says that x has to be greater than 1, because if x was less than 1, then we'd try and take the log of a negative number, which is not allowed. This log says greater than 0, so we've got, from the first term, we know that x has to be greater than 1. We also know from the second term that x has to be greater than 0. The third term just says that x has to be greater than negative 9, so that the argument does not become negative. And the fourth term is a constant, so we don't have to stress about it. Now, out of those three, greater than 1, greater than 0, greater than negative 9, basically all of our solutions have to be greater than 1. Any solution that's not greater than 1, we are not allowed to include because it's not in the domain of the original problem. So that means that while both of these solutions are good answers to the quadratic problem, only x equals 6 is a solution to the original problem. We have to discard the x equals minus 3 because it doesn't fit in the domain. And that is where a lot of people end up getting tripped up with these logarithmic equation questions. Alright, that's all there is for this question. I'll see you guys on the next one.